Imagine a moment etched in history. August 23rd, 2023. On this day, India's Chandrayaan-3 spacecraft accomplished a feat never before achieved. A successful landing on the moon's south pole, a hidden realm forever turned away from our earthly gaze. But what secrets does this uncharted lunar territory hold that has captivated the minds of scientists? The answer lies in a precious resource: lunar ice. This region is believed to possess a greater abundance of this frozen treasure than the areas explored in the north. The excitement surrounding this discovery is palpable. This ice represents a frozen reservoir of water, potentially the key to establishing a permanent outpost on the moon and even fueling ambitious voyages to Mars. The existence of this lunar ice has been suspected for over 2 decades, ever since a NASA spacecraft inadvertently detected it during a mission. In 2018, NASA confidently confirmed its presence, declaring the moon's south pole to be rich in water. Envision a future where lunar settlers can tap into this vast water supply, sustaining life in the desolate lunar landscape. By ingeniously breaking down the water into oxygen and hydrogen, they could gain both breathable air and rocket fuel. This would make lunar missions more sustainable and self-sufficient. Furthermore, this ice offers a tantalizing glimpse into the past. Potentially as old as the moon itself, it could unlock profound mysteries about the moon's formation and the early history of Earth. But here's a surprising revelation: water isn't a rarity in the cosmos. Countless planets may harbor the potential for life. We've detected water vapor surrounding distant stars, and remarkably, this water bears a striking resemblance to the water found in our own solar system. This suggests that Earth's water may have originated from space. Water forms within clouds of intensely hot vapor surrounding stars. As it cools, it transforms into ice, clinging to minuscule dust particles. Over vast stretches of time, these particles coalesce, forming larger bodies like comets and planets. Some of these icy objects eventually found their way into our solar system, potentially delivering water to both Earth and the moon. Scientists propose that the lunar ice embarked on its journey eons ago, perhaps hitching a ride on water-rich asteroids that collided with the moon's surface. These discoveries have far-reaching implications. The southern pole presents an ideal location for humanity to establish a moon base. Picture interconnected brick domes, linked by secret underground tunnels, bustling with activity as people operate computers and explore the lunar terrain in specialized vehicles, mining valuable resources. We have ambitious plans for constructing this lunar habitat. Instead of transporting bulky, resource-intensive shelters from Earth, we can draw inspiration from our own history. Throughout our civilization's expansion, we've adapted to new environments by utilizing local resources for survival and growth. What resources does the moon offer? Beyond the ice, which can be transformed into water, the moon possesses mineral wealth and abundant sunlight. Unlike Earth, where the sun rises and sets, the lunar poles experience a unique phenomenon. The sun gracefully circles the horizon, providing a nearly constant source of energy. Imagine living in a world perpetually bathed in sunlight, a dream for solar panels. We can harness not only the sun's light, but also its heat. We should strive to utilize every available resource. Any leftover metal from oxygen production should be repurposed. Responsible environmental practices are essential, both on Earth and on the moon. Scientists are exploring ways to transform the moon's most abundant resource, regolith, into durable bricks. They are devising innovative methods for creating these lunar bricks, including using the sun's heat to melt lunar dust layer by layer, essentially creating a 3D printer that utilizes moon dust as its raw material. Engineers have also cooked. Imagine a lunar landscape transformed, not by towering cities, but by humble brick factories. Using ingenious solar ovens, astronauts might one day bake lunar soil into sturdy bricks, or perhaps zap the regolith with focused microwaves, becoming masters of lunar construction. Picture it, a real-life Minecraft unfolding on the moon, where every new material discovery leads to the creation of a new lunar home. These bricks, if the concept proves viable, could form the very foundations of entire structures. They could become protective shells for inflatable modules, or breathe new life into the silent hulks of abandoned landers. Will future astronauts become expert bricklayers? Perhaps not entirely. The vision involves a collaborative effort between humans and robots, a small automated system under human supervision. Despite the automation, scientists envision a surprisingly comfortable lunar existence. Imagine living quarters stacked like cozy apartments or multi-purpose areas designed for efficiency. But the moon, despite its allure, is a realm of extremes. Picture this: scorching temperatures reaching a blistering 212 degrees Fahrenheit during the lunar day, then plummeting to a bone-chilling 290 degrees at night. And it's not just the temperature. The lunar surface faces a relentless barrage of solar radiation, cosmic rays, and micrometeorite impacts, all slowly eroding any structure exposed to their fury. Then there's the lunar dust, a pervasive menace. The moon's vacuum offers no air to breathe, and the dust itself presents a unique set of challenges. This isn't just ordinary dust. It's super clingy, capable of triggering sneezing fits and watery eyes in astronauts, a kind of lunar hay fever. It can also wreak havoc on equipment and spacesuits, a substance to be treated with extreme caution. Scientists have discovered that this troublesome dust originates from meteor impacts, creating microscopic particles and sharp glass shards. This toxic dust can float ominously in the weak lunar gravity, posing a breathing hazard. Unlike Earth, the moon lacks wind or rain to clear away this ever-present threat. Researchers are now intensely studying the lunar dust, seeking ways to mitigate its potentially mission-crippling effects. But the moon holds more than just construction challenges and pesky dust. Scientists are also eager to explore the mysteries hidden within low-frequency electromagnetic waves. These waves, faint whispers from the distant universe, have long eluded our grasp, drowned out by Earth's cacophony of radio waves and background noise. The far side of the moon, however, offers a unique opportunity: a radio quiet zone where these elusive signals can finally be captured and studied. By studying these waves, scientists hope to unlock profound secrets about the universe's very origins. This isn't just about our planet or its moon. It's about peering back into the cosmic dawn. A lunar laboratory could forever alter our fundamental understanding of the cosmos. NASA has ambitious lunar plans. The Artemis mission, which successfully returned to Earth in December 2022 after nearly a month in space, ventured far beyond the moon, proving the capabilities of new technologies crucial for future Mars exploration. The ultimate goal of Artemis is to establish a lasting lunar presence, creating a gateway, a space station in lunar orbit, to facilitate landings. Artemis 2 is slated to carry astronauts into lunar orbit in 2024, and Artemis 3, planned for the mid-2020s, will see 2 astronauts land near the moon's south pole. A permanent lunar base could become a reality within the next few decades. So, stay tuned, for the future of space exploration is rapidly unfolding. While high-tech telescopes grant us incredible views of the lunar surface, some regions remain stubbornly hidden. The moon's south pole harbors giant craters that have remained in perpetual darkness for eons, colder than Pluto, and nearly impossible to explore. But these shadowy depths may hold the key to unlocking humanity's spacefaring future. They are believed to contain essential resources, most importantly water, trapped as tiny ice crystals within the lunar soil. Water in space is a game changer. As you may know, scientists are equally determined to find water on Mars. The presence of subsurface water on the red planet would dramatically increase the chances of finding extraterrestrial life. Imagine a discovery that would rewrite history itself. The faintest trace of life, even microscopic, on another world would be monumental. That's precisely why robotic explorers tirelessly roam the rusty plains of Mars, meticulously drilling into the Martian soil, like dedicated gardeners tending to an alien landscape. And while the discovery of water on Mars would be a game changer, finding water on our own moon might hold even greater immediate value for humanity. The reasons are rooted in simple logistics, distance, and gravity. Our lunar neighbor is a mere 3-day journey away, a cosmic hop, skip, and jump compared to the vast distances of the solar system. To put it in perspective, A leisurely cruise from London to New York consumes over a week. But the moon's true potential lies in its role as an orbital pit stop, a place to refuel and relaunch, paving the way for deeper space exploration. The moon's gravity is a mere fraction, 1/6 of Earth's pull. This isn't just a recipe for low-gravity acrobatics, it's a fundamental advantage for space travel. Launching rockets from the moon requires significantly less energy than escaping Earth's heavy gravitational embrace. Think of the Saturn V rocket, the behemoth that propelled the Apollo missions to the moon. A staggering 90% of its mass was fuel, solely dedicated to overcoming Earth's gravity. On the moon, the equation flips. Rockets can carry heavier payloads with vastly reduced fuel requirements. It's akin to being able to pack an enormous suitcase without exceeding the weight limit. If we can locate and harness lunar ice to manufacture rocket fuel, our moon transforms into a practical and cost-effective stepping stone for venturing further into the solar system. And the benefits don't stop there. With some basic chemistry, we could extract breathable oxygen and rocket propellant from lunar water. Plus, future lunar inhabitants will need water for drinking and cultivating crops in lunar bases. So, what tantalizing clues have we already uncovered? For decades, conventional wisdom held that the moon was bone dry, but in 2009, NASA dramatically shattered that notion by intentionally crashing a rocket into a lunar crater. The impact unleashed a spectacular plume of ice and vapor, a celestial fireworks display that definitively confirmed the presence of lunar water. But how much water are we talking about? Enough to matter indeed. Current data suggests hundreds of millions of tons of water ice are locked away in the perpetually shadowed polar regions. Some estimates venture as high as 1.3 trillion pounds, roughly the mass of 460 million cars. Not lunar lakes, perhaps, but a substantial and invaluable resource, and the possibility of even greater reserves remains. This lunar ice also holds the key to unlocking long-held scientific secrets. This ancient ice is a time capsule from the solar system's infancy. By analyzing these frozen molecules, we might unravel the mystery of how water arrived on the moon and, perhaps, how it first appeared on Earth itself. The next question, of course, is how did all this water end up on the moon? Scientists believe that comets and asteroids, billions of years ago, may have delivered icy payloads to the lunar surface. As these space rocks crashed, some of their water ice migrated to the frigid polar regions. Another contributing factor could be the interaction between the solar wind and the lunar soil. Regardless of its origins, the crucial element is the location of this ice, nestled within the permanently shadowed craters of the lunar poles. While ice deposits may exist elsewhere, the largest and most stable reserves are believed to reside in these polar craters. Some of these craters are truly immense. The Shackleton crater, for example, stretches over 13 miles wide and plunges more than 2 miles deep, nearly twice the depth of the Grand Canyon. The moon's axis barely tilts, a mere 1 degree. As a result, the sun never crests the rims of these deep polar pits, allowing temperatures to plummet to a bone-chilling 400-degree ref. Any water or volatile compounds trapped in that frozen soil remain locked in place, preserved in a perpetual deep freeze. Intriguingly, the lunar South Pole offers a unique juxtaposition. Regions shrouded in eternal darkness exist alongside mountain ridges, basking in almost constant sunlight. Scientists call these sun-drenched peaks the peaks of eternal light. These sunlit highlands are ideal locations for solar panel arrays, providing a sustainable power source while remaining in close proximity to the icy treasures hidden in the shadows below. The lunar poles are unique places where eternal day and night coexist. But this eternal night isn't just a scientific curiosity, it's a treacherous environment. The terrain is unforgiving. Imagine a place so alien, so utterly different from anything we know, that our current technology struggles to even comprehend it. We can't even begin to recreate such conditions here on Earth. It's like trying to navigate the most remote reaches of Antarctica, blindfolded, with both hands tied behind our backs. Now, knowing that potential water exists in these shadowed craters, the question becomes, can we actually get to it? That single question represents a potential investment of trillions of dollars. Yes, water is likely present, but extracting it won't be as simple as scooping ice cream from a bowl on a hot summer day. What we're really talking about are microscopic crystals of ice, intimately mixed with pervasive lunar dust. To access this precious resource, specialized machines will be required. These machines would need to excavate and heat the lunar soil, carefully capturing the resulting vapor before it dissipates back into the vacuum of space. A truly difficult engineering task. And then there's the relentless, all-encompassing cold. Even if a human explorer or a sophisticated rover could safely descend to the bottom of one of these perpetually shadowed craters, navigation would be incredibly challenging. Batteries would drain rapidly, equipment would fail under the extreme conditions, and solar panels would be rendered useless in the complete absence of sunlight. Electronic components would freeze solid in mere minutes. However, NASA's Lunar Reconnaissance Orbiter is already using advanced radar and sensors to remotely map the interiors of these mysterious craters. Now, a new and even more powerful tool has come online. Shadow Cam. This revolutionary camera is so sensitive that it can capture details in light levels 100 times fainter than what the human eye can perceive. Essentially, it's the ultimate night vision device. With Shadow Cam, we can finally create detailed maps of these hidden lunar landscapes without ever setting foot inside them. That's why engineers are working tirelessly to develop innovative solutions. Some concepts involve nuclear-powered rovers equipped with powerful headlights capable of piercing the darkness. Other proposals feature robots that rappel down the crater walls or even hop across the crater floor like futuristic pogo sticks. There are even ideas for specialized drills that could melt the frozen soil and capture the released water vapor, much like condensation forming on the outside of a cold soda can on a humid summer day. The good news is that this water isn't going anywhere. Until our technology catches up, this valuable resource will remain patiently waiting for us. And space agencies are already making significant strides. In fact, over half a dozen new lunar missions are planned for the next few years. NASA's Artemis program is preparing to send astronauts back to the moon, with a focus on the South Pole region. China's Chang'e 7 mission is specifically designed to investigate these permanently shadowed craters, and private companies like Firefly and Blue Origin are developing systems to deliver equipment and conduct experiments on the lunar surface. Now, here's a fascinating and often overlooked fact. The moon has a distinct smell. When the Apollo astronauts brought lunar dust into their landing modules, it interacted with the oxygen inside, producing a surprisingly strong odor. The astronauts described the smell as being similar to burnt gunpowder or spent fireworks. While lunar dust has nothing to do with gunpowder chemically, its particles are incredibly reactive. After being exposed to the vacuum of space for billions of years, these particles instantly reacted with the oxygen in the cabin, creating that characteristic smoky smell. Future lunar explorers will undoubtedly notice this smell as well, as lunar dust tends to cling to everything. Let's hope that, among their many other priorities, scientists will develop effective air fresheners for future lunar bases. What we see is a typical lunar crater. It exists because, in the distant past, an asteroid impacted the moon's surface with tremendous force. Lunar craters are formed when asteroids, meteoroids, or comets collide with the moon. As you can clearly see, such impacts have been a frequent occurrence throughout the moon's history. But one particular crater formed in a vastly different way. But how did it form? Let's rewind the clock. Billions of years. There is a widely accepted theory that the moon itself is the result of a colossal impact, much like the craters that now scar its surface. However, this collision was on a scale almost unimaginable. Over 4.5 billion years ago, a Mars-sized protoplanet called Theia crashed into the early Earth. This cataclysmic event ejected vast amounts of debris into orbit around our planet. Over time, this debris coalesced under the force of gravity, eventually forming the moon. For a significant period after its formation, the moon was essentially a giant ball of molten lava. Because the young moon was much closer to Earth than it is today, our planet's powerful gravity constantly squeezed and distorted it, generating immense heat. Eventually, however, the moon gradually drifted further away from Earth, cooled down, and developed a solid rocky crust. Now, fast forward to approximately 4.3 billion years ago. An asteroid the size of a small country, imagine Nepal, far larger than the asteroid that ultimately led to the extinction of the dinosaurs, slammed into the far side of the moon. This impact created an enormous depression known as the South Pole Aitken Basin. This colossal scar is up to 8 miles deep and approximately 1,500 miles in diameter. For comparison, that's roughly the distance from New York to Kansas. Imagine a crater so immense it could swallow Mount Everest whole. That's the South Pole Aitken Basin on the moon. Now, scientists are beginning to suspect that the colossal impact which created it may have unearthed and scattered ancient material from deep within the lunar interior. This material, a unique mixture dubbed CREEP, an acronym for potassium, rare earth elements, and phosphorus, is like a chemical time capsule. It offers a glimpse into the moon's primordial past, back when it was still a molten ocean of lava. But here's where the story takes an unexpected turn, potentially making this region even more scientifically valuable than previously imagined. Until recently, researchers operated under the assumption that the asteroid responsible for the basin struck from the south. This would have sent radioactive CREEP material swirling northward, accumulating around the crater's northern rim. However, after meticulous re-examination of the evidence, scientists have made a startling realization. The impact actually originated from the north. This means that the treasure trove of CREEP is concentrated on the southern edge of the basin, not the north. And what makes this even more exciting? NASA's upcoming Artemis 3 mission is targeting that very southern region. The shift in thinking began when researchers compared the South Pole Aitken Basin to other massive impact structures across the solar system, specifically the Hellas Basin on Mars and the Sputnik Planum on Pluto. Take a look. All three share an unusual teardrop or avocado-like shape, wider on one end and tapering to a point on the other. Crucially, that pointed end typically indicates the direction from which the impacting object arrived. In the case of the South Pole Aitken Basin, this strongly suggests a northern origin for the asteroid. To bolster their hypothesis, scientists delved into archived data from NASA's Lunar Prospector mission, which orbited the moon in 1998 and 1999. This spacecraft measured the distribution of radioactive elements on the lunar surface and found elevated concentrations of thorium, a telltale component of CREEP, clustered around the southwestern rim of the basin. Now, the Artemis 3 mission represents NASA's ambitious endeavor to return humans to the moon for the first time since 1972. If all proceeds as planned, the launch is tentatively scheduled for mid-2027, closely following the completion of the Artemis 2 mission. Artemis 2, slated for launch before April 2026, will serve as a critical dress rehearsal. Astronauts will orbit the moon without landing, meticulously evaluating all systems to ensure seamless operation. A cosmic shakedown cruise, if you will. Artemis 3 is where the real adventure begins. Astronauts are slated to land near the moon's south pole, at one of 9 candidate sites carefully selected by NASA. The challenge, however, lies in the timeline. Both Artemis 3 and Artemis 2 have already faced delays. Artemis 1, launched in 2022, was a successful uncrewed test flight that circled the moon and returned safely. Next in line is Artemis 2, which will carry astronauts further into space. Then comes Artemis 3, the main event. Astronauts are expected to spend approximately a week on the lunar surface, conducting scientific investigations before returning to Earth. Following that, Artemis 4 and 5 will focus on constructing and expanding a new miniature space station in lunar orbit known as Gateway. Think of it as a pit stop strategically positioned in space. Astronauts can dock there, reside for short periods, conduct experiments, and prepare for lunar landings. NASA is collaborating with the European Space Agency, Japan, and other partners in its development. Astronauts will journey to the moon aboard the Orion spacecraft, launched by NASA's Space Launch System, SLS, a colossal rocket towering taller than the Statue of Liberty, possessing the immense power required to propel humans to the moon. To actually descend to the lunar surface, they will utilize the Human Landing System, HLS. SpaceX's Starship is slated to make the initial descent to the lunar surface, pending successful demonstration of its landing capabilities. Looking ahead, NASA's ambitions extend far beyond the moon. The ultimate objective is Moon to Mars. The intent is to leverage the knowledge gained from the Artemis program to establish a lunar base and ultimately send humans on the long voyage to Mars. And who knows what other mysteries might be unraveled when humans once again set foot on the moon. Perhaps they'll shed light on the enigmatic transient lunar phenomena, the fleeting flickers, glows, or beams of light that occasionally illuminate our celestial neighbor. Let's delve deeper into this enigma, shall we? On the night of April 19th, 1787, the renowned astronomer William Herschel observed an anomaly, a brilliant light emanating from the dark side of the new moon. This glow persisted for hours, nearly matching the brightness of the Orion Nebula. What he witnessed was likely a transient lunar phenomenon, or TLP. These are essentially short-lived flashes or color variations on the lunar surface, and their origin remains a puzzle. Imagine gazing up at the moon and witnessing strange, fleeting glows. These aren't tricks of the light, they're transient lunar phenomena, or TLPs. We might see them as glowing patches, reddish or purplish spots, or even hazy clouds that materialize and vanish without warning. For 2 millennia, stargazers have documented these lunar anomalies, recording some 3,000 instances with telescopes, cameras, and the naked eye. But what triggers these eerie flashes? There's no single explanation. Meteor impacts, escaping gases, and even electrical discharges can all contribute to TLPs. The duration of a flash, ranging from a fraction of a second to several hours, holds vital clues for scientists deciphering the mystery behind each lunar light show. The briefest flashes, lasting less than a minute, are often caused by tiny space rocks colliding with the moon. Even a meteoroid the size of a billiard ball can strike the lunar surface with enough force to produce a momentary glow. The intense heat from the impact causes the surrounding rock to incandesce before rapidly cooling and fading. Scientists suspected meteoroid impacts were the culprit for these fleeting flashes, but definitive proof remained elusive until the 1990s, when high-speed cameras became commonplace in lunar research. Even with advanced technology, confirmation wasn't easy. Short flashes could be mistaken for camera malfunctions or electrical interference. The only way to be certain was to capture the same flash simultaneously from multiple locations. This breakthrough occurred during the Leonid meteor shower in 1999, when scientists successfully recorded genuine impact flashes on the moon. This event provided further evidence that the moon is constantly bombarded by space debris. While these flashes appear more frequently in regions like Oceanus Procellarum, a vast, dark plain on the lunar surface, this is likely due to observational bias. Scientists tend to focus their cameras on these areas. A 2024 study revealed that meteoroids strike the moon uniformly across its surface. Flashes lasting several minutes likely have a different cause: gas emanating from the moon's interior. Research from 2008 and 2009 suggests that gases like radon can accumulate beneath the lunar surface, eventually erupting in sudden bursts. As this radioactive gas escapes and decays, it emits a faint glow visible from Earth. These glowing spots often correlate with regions known to have elevated radon levels. Then, there are the long-duration events, lasting for hours. One such event was observed by William Herschel in 1787. A 2012 study proposed that these prolonged glows might be caused by the solar wind, a stream of charged particles emitted by the sun. When the solar wind interacts with lunar dust, it can electrify the particles and propel them into space, forming massive dust clouds extending up to 60 meters above the surface. These floating clouds could refract or reflect light from distant stars or planets, creating the illusion of a glowing moon. Hopefully, NASA's Artemis mission will provide answers when astronauts land and begin their exploration. In 2024, Earth temporarily acquired a mini-moon that orbited our planet for a couple of months. It circled the Earth a few times and then departed, resuming its orbit around the Sun. However, astronomers have now identified another celestial object that has been accompanying Earth for 6 decades. This rare and peculiar object is classified as a quasi-moon. But what is a quasi-moon? Unlike our familiar moon, which lights up the night and influences tides, a quasi-moon doesn't orbit Earth directly. Instead, it orbits the sun, maintaining a synchronized dance with our planet. Imagine a runner keeping pace with you in a marathon. Space may appear tranquil, but it's a dynamic environment. The sun, moon, Earth, and other planets constantly exert gravitational forces on each other and smaller objects like asteroids. Most asteroids cannot maintain this delicate balance for long. They are either nudged into different orbits, pulled closer to Earth, or flung into the vastness of space. That's why spotting more than a couple of quasi-moons at a time is rare. They are part of a larger group known as co-orbitals. Astronomers classify these co-orbitals into several categories. These celestial wanderers dance around our planet, their movements dictated by the intricate ballet of gravity. Unlike our steadfast lunar companion, these cosmic visitors are not permanent residents. Some may grace our presence for decades, while others linger for centuries before being lured away by the gravitational embrace of another celestial body. It's akin to a dog, drawn away from its owner by the irresistible aroma of bacon wafting from a neighbor's yard. One defining characteristic of these quasi-moons is their diminutive size. Most are no larger than buildings, and some are even smaller. Their faint luminosity allows them to remain hidden in plain sight, blending seamlessly with the backdrop of distant stars. Yet, despite their elusiveness, they hold significant scientific value. By studying these near-Earth objects, astronomers gain invaluable insights into their movements and the duration they can remain ensnared by Earth's gravitational pull. Quasi-moons, being closer than other asteroids sharing similar trajectories, offer a more accessible target for exploration. It's conceivable that one day they could serve as stepping stones in our ambitious endeavors of space exploration. Earth has played host to several of these temporary companions. One of the most renowned is 2016 HO3, affectionately known as Earth's constant companion. Despite its modest size, measuring only about 300 feet across, it has been faithfully orbiting alongside us for nearly a century. Researchers speculate that it may continue its celestial dance with Earth for centuries to come. But what about the most recently discovered quasi-moon? Designated 2025 PN7 by the researchers, it has already been in our vicinity for 6 decades and is projected to remain for approximately 68 more years. Its diminutive size, a mere 62 feet in diameter, roughly the length of a bowling lane, is the reason it remained undetected for so long. This also explains why you couldn't simply spot it in the night sky, even if you knew exactly where to look. The origins of this celestial wanderer remain shrouded in mystery. Astronomers have yet to determine its composition. Currently, its trajectory is the only known characteristic. While some quasi-moons are simply near-Earth asteroids that have fallen into a peculiar orbit, others bear a striking resemblance to fragments of our own moon. Take, for instance, Kamoa Loa, another quasi-moon, which reflects light in a manner nearly identical to the lunar rocks brought back from the Apollo missions. This has led some researchers to believe that it may be a remnant of a massive impact that occurred eons ago. Then there's 2024 PT5, a temporary mini-moon that graced our skies at the end of the previous year. Tests revealed that its surface resembled lunar basalt, further suggesting a lunar origin. So, how do these quasi-moons maintain their delicate cosmic equilibrium? It's an orbital illusion in reality. Remember, PN7, like its fellow quasi-moons, isn't truly orbiting our planet. From our perspective, it appears to trace lazy loops around Earth's path, like whimsical doodles etched in the vast expanse of space. However, it never strays too far or lags too much. Astronomers refer to this phenomenon as a one. Resonance. Put simply, it completes one revolution around the sun for every revolution Earth makes. Another intriguing question arises. If these fake moons are so close to Earth, why don't we simply reel them in with our gravity? Especially considering their small size and apparent proximity. The answer lies in the fact that despite being classified as near-Earth objects, quasi-moons are not as close as they seem. Our familiar moon resides at an average distance of 239,000 miles. These temporary companions, however, orbit the Sun millions of miles away, far beyond Earth's gravitational reach. That reach extends within an area known as the Hill sphere, where Earth's gravity reigns supreme over the Sun's. Imagine Earth's gravity as a bubble with a radius of approximately 1 million miles. Anything venturing inside this bubble is susceptible to Earth's gravitational embrace, like our real moon. Step outside, and the Sun assumes control. This is precisely what transpired with PT-5, which briefly became our legitimate satellite for 2 months in 2024. It dipped within the Hill sphere, and Earth's gravity took hold. Once captured, it was christened a mini-moon. However, due to its small size and rapid velocity, it eventually slipped back out of the bubble, and the Sun's gravity reclaimed it. In addition to quasi-moons and mini-moons, there exists another type of co-orbiter known as horseshoe orbiters. These space rocks maintain a relatively close proximity to Earth, but from our vantage point, they appear to swing ahead, decelerate, then drift back behind, repeating this cyclical pattern. It's akin to an undercover police car tailing you in traffic, constantly switching lanes and doubling back to avoid detection. If you were to trace their motion from Earth over time, it would form a massive horseshoe shape, hence the name. And these are just some of the many celestial. But the story doesn't end with co-orbiters. The universe holds even more surprises. Far, far ahead of our planet, and equally distant behind us, lurk peculiar celestial bodies known as Trojans. These aren't simply tagging along like quasi-moons. They've discovered 2 unique hiding places, one positioned 60 degrees in front of Earth, and the other 60 degrees behind. Imagine cycling alongside friends, one consistently ahead and another trailing behind, both maintaining the same pace. That's the essence of how Trojans behave. These strategic locations are called Lagrange points, stable zones where the gravitational forces of both Earth and the Sun achieve a perfect equilibrium. Objects finding themselves within these zones can remain there for millions of years, undisturbed. Jupiter, the giant of our solar system, is a notorious collector of these cosmic hitchhikers. Earth, comparatively, has only a handful. Then we have the tadpole orbiters. Instead of remaining stationary at a Lagrange point, they meander around it in languid bean-shaped paths. And if that wasn't bewildering enough, there exist jumping Trojans, the indecisive wanderers. These celestial objects can't seem to commit to one location. They might linger in the front hammock for several thousand years, then gradually drift to the one behind us, only to return again in an endless cycle. Rare, strange, and undeniably fascinating. So, while Earth boasts only one prominent moon in our night sky, we are actually accompanied by a whole entourage of space companions. Some trace loops, others follow, and some hide in the gravitational corners of our orbit. Let's quickly recap the superpowers of our primary moon. It governs our tides, gradually slows Earth's rotation, and even stabilizes our planet's axial tilt. Without the moon, our days would be shorter, our nights darker, and our seasons far more unpredictable. The moon also serves as a colossal shield, attracting or deflecting space debris that might otherwise collide with Earth. And of course, we can't overlook its cultural significance. It has fueled myths, calendars, love songs, and countless melancholic nighttime strolls. Fake moons can hardly compete with that legacy. However, these minor companions are valuable in their own right. Each new quasi-moon discovery helps us to unravel the mysteries of how these small rocks survive in the vast cosmic chaos. By understanding our environment, we gain insight into ourselves. They hone our detection capabilities and refine our predictive models. So, while they may never illuminate the night sky, they quietly contribute to our understanding of our peculiar cosmic neighborhood. But hold on, the plot thickens. Earth may have more than just these quasi-moons. What if I told you Earth has not 1, not 2, but potentially 7 moons? Or maybe even more. This revelation reshapes our entire perception of our place in the cosmos, doesn't it? Does this imply we might colonize 7 celestial bodies instead of just one, establishing 7 lunar bases? Will future space travelers have a choice of which natural satellite to spend their vacations on? Well, here's the catch. These additional moons are somewhat different. They're classified as mini-moons. Now, there's no universally accepted definition of a mini-moon, because naturally, scientists rarely agree on anything unanimously. But the general principle is that it's a space rock that temporarily becomes trapped by Earth's gravity, completes at least one orbit around our planet, and at some point passes relatively close, within approximately 4 lunar distances. Essentially, if it approaches close enough to cause excitement among astronomers, it qualifies. Our Earth periodically captures these miniature moons. They swing by, linger for a while, and then continue their journey to orbit the Sun. Occasionally, fragments of space debris are ensnared by Earth's gravitational pull, orbiting us temporarily, like houseguests crashing on our couch before resuming their travels. A sort of cosmic speed dating. Initially, scientists believed that most of these mini-moons originated from the asteroid belt, that vast collection of space rubble situated between Mars and Jupiter. However, recent discoveries have complicated this picture. It seems that some of these tiny moons might actually be fragments of our own moon. A notable example dates back to 2016, when a telescope in Hawaii detected an unusual object orbiting near Earth. It was named Kamo-Oalewa, which sounds like a relaxing vacation destination, but is actually a 328-foot-wide space rock orbiting the Sun in sync with Earth. Subsequent studies suggested that it likely broke away from the Moon between 1 and 10 million years ago. Imagine the cataclysmic impact that created the Giordano Bruno crater. And recently, another. Then, in 2024, another intriguing object appeared. 2024 PT5. And what did it resemble? Surprisingly, it looked far more like a fragment of the Moon than a typical asteroid. Naturally, this sparked intense curiosity among researchers, who immediately began crunching the numbers. One of these scientists, Robert Jedicke, a leading expert on mini-moons, and his team conducted extensive simulations. Their goal? To determine how frequently lunar fragments might find themselves orbiting our planet. The results were fascinating. A significant amount of lunar debris can, in fact, be captured by Earth's gravitational pull, at least temporarily. Approximately 20% of this captured material could potentially become genuine mini-moons. The best estimates suggest that there might be around 6 or 7 of these small lunar or space pebbles currently orbiting Earth. However, their stay is not permanent. These mini-moons have a tendency to wander off. On average, they remain in Earth's orbit for about 9 months before departing. Fortunately, the supply of space debris in Earth's vicinity is constantly replenished, ensuring a steady turnover of these temporary satellites. However, it's crucial to acknowledge that these figures are far from precise. Jedicke himself admitted that the level of uncertainty is ginormous, essentially saying that these are educated guesses. The problem lies in the many unknowns, such as the magnitude of moon impacts, the velocity of the ejected fragments, and even the limitations of our telescopes in detecting such small objects. Therefore, while these predictions are the best we have, they could be significantly off the mark. But that's the nature of science, formulating hypotheses, testing them, and refining our understanding through ongoing investigation. In any case, spotting these mini-moons is a formidable challenge. They are typically about the size of a car or a small SUV, ranging from approximately 3 to 7 feet in diameter. While that might seem substantial when maneuvering into a parking space, it's a mere speck in the vastness of space. Basically, a cosmic breadcrumb. The primary difficulty stems from their diminutive size and rapid motion. To be visible, they must pass relatively close to Earth to reflect sufficient sunlight. However, at such close proximity, they streak across the sky with incredible speed, making them exceedingly difficult to track, even with advanced telescopes. This elusiveness is a source of concern for scientists. What if one of these mini-moons were to enter Earth's atmosphere? The consequences could resemble the Chelyabinsk event. Let's rewind to a seemingly ordinary morning in Chelyabinsk. Suddenly, the calm was shattered. A blinding flash of light, brighter than the sun, illuminated the sky, followed by a deafening sonic boom that reverberated across the region, shattering windows and disrupting daily life. The date was February 15th, 2013. Without warning, a space rock, roughly the size of a house, hurtled into Earth's atmosphere at a staggering speed of over 11 miles per second. Approximately 14 miles above the ground, it exploded in midair, releasing a tremendous amount of energy. The resulting shockwave caused widespread damage, sending shards of glass raining down on homes, schools, and offices. Over 1,600 people sustained injuries, primarily from flying debris. And remember, this was not a particularly large asteroid, merely a cosmic pebble compared to some of the larger objects lurking in space. Fortunately, according to Jedicke, modern sky surveys are surprisingly adept at detecting objects of this size, even from millions of miles away. However, there is a catch. These fast-moving objects tend to leave streaks in images, rather than appearing as distinct points of light. These motion trails pose a challenge for computer algorithms, making them harder to recognize. Consequently, many mini-moons slip by undetected. Despite these challenges, there is reason for optimism. Researchers emphasize that we did manage to spot one mini-moon, designated 2020 CD3, even though it was visible on only 2 out of 1,000 possible nights. That's akin to finding a needle in a haystack while the haystack is spinning. Once a mini-moon's location is known, tracking its trajectory becomes significantly easier. And here's where things become particularly intriguing. These tiny visitors might actually be valuable. Their proximity to Earth makes them far more accessible than asteroids in the asteroid belt. This opens the possibility that space mining companies might one day attempt to capture a mini-moon and extract its valuable resources. From a scientific perspective, mini-moons are also of considerable interest. They could provide valuable insights into the formation and evolution of the solar system. By studying how fragments of the moon are ejected and transformed into orbiting debris, we might even gain a better understanding of the potential damage that a larger asteroid impact could inflict on Earth. So, while these mini-moons may be elusive, fast-moving, and somewhat unpredictable, they hold a wealth of scientific secrets waiting to be unlocked. By the way, Earth might imagine, millions of years ago, our planet Earth looked up at a night sky featuring not one, but 2 moons. Yes, 2 celestial companions graced our prehistoric skies. One was the moon we all know and love, the familiar beacon in the night. The other? A smaller tag-along buddy moon, a cosmic little brother. But this idyllic scene wasn't destined to last. What happened to this second moon? For decades, scientists have puzzled over a peculiar asymmetry. The near side of our moon, the face it always presents to Earth, is smooth and relatively flat. Conversely, the far side, the one perpetually hidden from our view, is a rugged landscape of bumps, crusts, and a significantly thicker crust. It's as if the moon has a carefully curated selfie side and a please no photos side. Now, a compelling new theory has emerged, supported by sophisticated computer modeling. This theory suggests that the moon's lopsided appearance is the result of a slow-motion cosmic collision. Picture this. Eons ago, our moon had a smaller sibling, a fellow moonlet, orbiting alongside it. For a staggering 80 million years, a cosmic harmony reigned. Both moons, born of the same stuff, shared a similar composition and coloration. The only difference? Size. One was about 3 times larger than the other. But the relentless pull of gravity intervened. As the 2 moons gradually drifted further from Earth, the sun's gravitational influence began to assert itself. This solar tug subtly altered the smaller moon's trajectory, setting it on a collision course with its larger sibling. The impact wasn't a Michael Bay-esque explosion. Instead, imagine a slow, inexorable crunch. The collision occurred at a speed insufficient to melt rock, but with enough force to effectively smear one moon across the other, like cosmic Play-Doh being molded by an unseen hand. The smaller moon didn't leave a distinct crater. Instead, it spread itself across the far side, contributing to the mountainous, heavily textured terrain we observe today. The aftermath was a period of intense cosmic chaos. Trillions of tons of lunar debris were ejected into orbit, enveloping the Earth-Moon system in a cloud of dust, rocks, and fragments. For what must have seemed like an eternity, Earth was bombarded with lunar shrapnel. Some of these space rocks were colossal, rivaling the size of cities. So, our moon, that serene orb in the night sky, may actually be a composite of two celestial bodies fused together in a slow-motion cosmic dance. One face smooth, the other forever scarred by the memory of its lost twin. A tragic yet epic tale etched onto the lunar surface. It explains why one side of the moon looks like it decisively lost a bar fight. But the moon holds more secrets than just its violent past. Remember the gold rush? Back in the 19th century, hordes of prospectors descended upon California's rivers, panning for gold, driven by the lure of unimaginable riches. Well, some scientists are now suggesting that it might be time for a lunar gold rush. The prize? Precious metals, potentially worth trillions of dollars, hidden beneath the moon's surface. The question is, can we realistically access these riches? And if we do, who gets to claim them? If you've ever examined high-resolution images of the moon, you've undoubtedly noticed its pockmarked surface, riddled with craters. Our celestial neighbor resembles a giant cosmic Swiss cheese. It boasts over 1.3 million craters, if you include those larger than 6 miles in diameter. But today, our focus is on the truly massive ones, the approximately 6,500 craters exceeding 12 miles in width. These aren't the work of little green men or subterranean moles. They are the scars of countless asteroid impacts, collisions that have punctuated the moon's history since its very formation. Scientists have compared lunar scans to the composition of meteorites. After meticulous analysis, they believe that these craters may harbor a treasure trove of platinum and other precious metals. What makes this prospect particularly enticing is the potential accessibility of these resources. Many of them could be located just a few feet beneath the lunar surface. The moon lacks Earth's protective atmosphere, and thus is without wind, rain, or seismic activity to disrupt the landscape. This means that the asteroid impacts effectively deposited their cargo of precious metals directly onto the lunar surface, where they have remained undisturbed for millions of years, preserved within the lunar dust. Each crater acts like a giant cosmic bowl, collecting platinum, iridium, palladium, and a host of other valuable metals. On Earth, extracting these elements requires drilling to extreme depths. Yet, on the moon, they may be lying just beneath our feet. And here's a fascinating fact. Much of the mineral gold on Earth likely originated from ancient meteorites. When Earth first coalesced, almost all of its original gold sank into the planet's core, making it inaccessible. The gold we can mine today is likely the remnants of space rocks that bombarded Earth billions of years ago. You might wonder, why not mine asteroids directly? The answer, of course, is proximity. While asteroid mining is theoretically possible, the moon is far closer and more accessible than any other substantial space rock. We've already walked on its surface, collected samples, and returned them to Earth. We are, in essence, intimately familiar with the lunar landscape. However, extracting these resources directly from the lunar surface is a much more logical approach than trying to intercept unpredictable asteroids in deep space. That being said, asteroid mining remains a tantalizing prospect for the future, but the potential bounty of lunar mining extends far beyond mere material riches. Imagine, nestled within the perpetually shadowed depths of certain lunar craters, lie reserves of frozen water. These aren't just theoretical deposits. Missions such as NASA's Lunar Reconnaissance Orbiter and India's Chandrayaan-1 have already confirmed the presence of water ice locked within the dark, frigid craters near the moon's poles. This lunar ice holds incredible value. It can be broken down through electrolysis into its constituent elements, oxygen and hydrogen. These are the very building blocks of rocket fuel. Furthermore, this water could be purified to provide drinking water for astronauts, or even used to cultivate plant life in lunar habitats. Envision spaceships being refueled directly on the moon before embarking on voyages to distant planets. Not only is this a captivating vision, but it also represents an incredibly economical and efficient solution. The savings in terms of money and effort would be astronomical. And if we're already establishing refueling stations, why not take the next logical step and create a permanent lunar base? We could transform the moon into a launch pad for deep space exploration. A fully functional moon base would offer scientists an unparalleled platform to study the volatile nature of space weather, refine the techniques for constructing off-world habitats, and rigorously test robotic systems in the abrasive environment of real lunar dust. I can't be the only one thrilled by the prospect of live feeds from lunar missions streamed directly to Earth by intrepid robots. The skills and knowledge acquired on the moon will become absolutely vital for establishing a presence on Mars, exploring the icy moons of Jupiter, and venturing even further into the cosmos. This isn't some far-fetched fantasy. Companies like Astroforge and Carmen Plus are already developing the technologies necessary to mine asteroids and, eventually, the moon. NASA's Artemis program is pushing hard to establish a sustainable human presence on the lunar surface within the next decade. And the European Space Agency is also keenly interested in exploiting lunar resources. Therefore, the idea of humans and robots collaborating to extract resources on the moon is almost certainly inevitable. However, the reality is more complex than it appears. Humanity faces some profound questions. Similar to the lawless chaos of the original gold rush, the rules governing lunar resource extraction remain ill-defined. The Outer Space Treaty of 1967 clearly states that no nation can claim sovereignty over the moon. However, it remains conspicuously vague about the rights of private companies to mine lunar resources. If a company builds a rocket and extracts a significant quantity of platinum, does that platinum belong to them? As it stands, the answer is unclear. Nations are currently engaged in intense debate, attempting to establish clear regulations before the burgeoning space gold rush descends into a chaotic, free-for-all battle for lunar resources. Then there's the critical issue of safeguarding the moon's unique and fragile environment. Certain lunar craters are so shielded from external interference that scientists dream of transforming them into massive space observatories, capable of studying the universe without the radio frequency interference that plagues terrestrial observatories. Mining operations in close proximity to these pristine sites could disrupt their delicate equilibrium, potentially contaminating them with lunar dust. This dust could damage sensitive instruments and compromise billion-dollar scientific experiments, much to the dismay of researchers. Furthermore, there are regions of the moon that remain virtually untouched by human activity. Mining activities could irreversibly alter or even destroy these pristine areas before we have the opportunity to fully explore and understand them. It's imperative that we avoid transforming the moon into a vast lunar construction site before we have had the chance to unlock its secrets. Some experts advocate for the establishment of protected zones on the moon, analogous to national parks on Earth, where mining and heavy industrial activities would be strictly prohibited. This approach would allow us to reap the benefits of lunar resources while simultaneously preserving the moon's most scientifically valuable regions for future research and discovery. But there's an even more fundamental question to consider. How will lunar resource extraction impact those of us who remain on Earth, unable to personally participate in the lunar gold rush? The rare metals found on the moon aren't just valuable, they could prove to be instrumental in shaping future technologies. Platinum group metals, which are likely present in lunar soil, are utilized in a wide variety of applications, including medical equipment, satellites, and even advanced batteries and fuel cells. If the moon truly holds trillions of dollars worth of these materials, it could stimulate technological innovation and potentially reduce manufacturing costs across numerous industries. The lunar surface also contains deposits of helium-3, a rare isotope that scientists believe could one day be used in nuclear fusion reactors. Fusion energy promises a clean, virtually limitless source of power that produces neither greenhouse gases nor long-lived radioactive waste. If fusion technology becomes viable, even relatively small quantities of helium-3 could provide enough energy to power entire cities. One of the amazing advantages of leveraging resources from the vastness of space is the potential to dramatically reduce the need for extensive excavation and the associated pollution here on our home planet. Imagine the possibilities. Less environmental degradation, and more sustainable strategies to support the ever-growing demands of humanity. However, this cosmic frontier also presents a new set of challenges. A monumental struggle for resources is inevitable. No nation, no corporation wants to be left behind in what could become a full-blown moon rush. The reality is that lunar mining transcends mere scientific exploration. It has the potential to reshape economies, revolutionize technology, and profoundly impact Earth's environment, for better or for worse. Remember those science books from our childhood, filled with images of bustling moon bases? One of the key reasons lunar exploration waned was a simple lack of financial incentive. Why dedicate vast resources to reach the moon if there appeared to be nothing of value there? But with the emerging understanding of the moon's hidden treasures, everything is poised to change. I can almost envision a future where I'm working a regular job on the moon, maintaining robots and cultivating lunar flora. But let's bring ourselves back to Earth for a moment. We're not quite ready to see a McDonald's franchise on the moon or book a stay at a lunar Airbnb. Even the most optimistic experts predict that large-scale mining operations and permanent lunar settlements are still decades away. For the foreseeable future, missions will primarily be robotic, experimental, and carry a price tag that will make your wallet weep. So, until we're all sporting moon mining helmets, it's a fascinating prospect to consider as we gaze up at the night sky. What secrets and riches are concealed on the moon's radiant surface? Now, imagine this. You're standing on the moon, and you can feel a deep, rhythmic pulsing beneath your feet. Danger seems to permeate every cell of your being. This seemingly lifeless satellite hesitates for a moment before a powerful tremor throws you to the ground. Is it a moonquake? For years, the prevailing scientific belief was that the moon was geologically inert. But recent evidence suggests this notion may be entirely incorrect. Researchers from the University of Maryland have recently identified 266 enigmatic ridges on the far side of the moon, and these formations strongly indicate recent geological activity. So, are we truly talking about moonquakes? Well, in a sense. These ridges are situated in volcanic regions that originated between 3.2 and 3.6 billion years ago, yet they appear surprisingly young. Typically found in clusters ranging from 10 to 40, they often occur in areas where the moon's surface exhibits structural weakness. Now, when astronomers use the term recent, it's important not to interpret it literally. They aren't referring to events of the past year or even the past decade. Most scientific models suggested that the moon's geological activity ceased 2.5 to 3 billion years ago. However, this new data hints at the possibility that these formations have been active within the last billion years. Some of the smaller ridges appear to have formed as recently as 200 million years ago, which is considered remarkably young on the lunar timescale. This implies that the moon may still be undergoing geological changes even today. These discoveries challenge our fundamental understanding of the moon's history and evolution. But how did scientists arrive at these conclusions? Researchers from the University of Maryland and the Smithsonian Institution employed a technique called crater counting to estimate the age of these lunar ridges. The principle is simple. Surfaces with fewer craters are younger, while regions with a higher concentration of craters are older. Furthermore, the analysis revealed that some ridges cut through pre-existing craters, suggesting they likely formed around 160 million years ago. In geological terms, this is incredibly recent, implying that the ridge-forming processes may still be active. Another intriguing aspect is the similarity between the ridges on both the near and far sides of the moon, suggesting they may have formed through the same geological processes, shaped by identical forces. These forces might include the moon's gradual shrinking, thermal contraction, and shifts in its orbit. And further supporting the idea of a still active moon is decades-old data from the Apollo missions. These missions had already detected shallow moonquakes with the Apollo Lunar Seismic Experiment. Imagine the moon, our celestial companion, a silent witness to Earth's history for billions of years. But beneath that serene glow lies a world still subtly shifting, still whispering tales of its tumultuous past. Recent studies have revealed moonquakes, tremors ranging from a gentle 1.5 to a more noticeable 5 on the Richter scale. Researchers are investigating whether these seismic events are connected to wrinkle ridges, formations that themselves suggest ongoing activity within our satellite. Now, let's consider the moon's gradual shrinking, a truly bizarre phenomenon. Scientists believe the moon came into existence roughly 4.5 billion years ago, born from a cataclysmic collision between a Mars-sized object and the young Earth. This colossal impact likely ejected vast amounts of superheated material into space, which eventually coalesced to form the moon we see today. In its infancy, the moon was a seething molten sphere, racked by intense volcanic eruptions and constant seismic activity. Picture it, a molten mess adrift in the cosmos. But when did this fiery orb finally solidify, its surface hardening into the landscape we recognize? The answer, according to recent findings, is approximately 4.43 billion years ago. This solidification was a pivotal moment, not only for the moon, but also for Earth. The very impact that birthed the moon may have delivered the final stabilizing blow that allowed Earth to become a habitable world, capable of supporting life. Billions of years rolled by. The moon steadily cooled, its volume contracting ever so slightly. And now we gaze upon a rocky sphere that illuminates our nights. However, the moon is not yet a completely rigid body. It continues to cool, and this gradual cooling of its core may be a key driver of its ongoing geological activity. As the interior cools, it shrinks, causing the lunar crust to crack and shift. One of the most visible manifestations of this contraction can be seen in the lunar maria. Look closely at those expansive dark patches on the moon's surface. These are the maria, vast plains formed when lava flowed into ancient asteroid impact craters and subsequently solidified. Over eons, the cooling and contracting crust has sculpted wrinkle ridges across these maria, further evidence of a dynamic, evolving landscape. Another contributing factor to the moon's geological activity may be its gravitational interactions with Earth. These relentless, powerful interactions likely induce stress on the lunar surface, triggering tectonic movements deep within. This all sounds fascinating, but can these lunar activities actually pose a threat to future human endeavors? In a very real sense, yes. The moon has long been envisioned as a potential site for future bases and resource extraction. However, the revelation of ongoing geological activity introduces significant concerns. If the lunar surface is still subject to shifting and cracking, future settlements, infrastructure, and mining operations could face substantial risks. Therefore, it is crucial that we deploy seismometers and ground-penetrating radar to gain a deeper understanding of these movements. This will allow us to accurately assess potential hazards before embarking on any long-term missions. And speaking of potential hazards, there's another challenge that future lunar explorers will undoubtedly confront: moon dust, also known as regolith. The Apollo astronauts quickly discovered that this fine, jagged, and surprisingly adhesive dust gets absolutely everywhere, wreaking havoc on suits, equipment, and even human health. A recent study by engineers at Texas A&M University has uncovered yet another problem. When rockets land or take off from the lunar surface, they stir up vast quantities of regolith, creating a potential collision hazard, especially as the frequency of spacecraft ferrying crews and cargo to the moon increases. Lunar regolith is composed of particles of all sizes, from microscopic dust grains to larger rocks. The primary component of moon dust is fine silicate material, typically around 70 microns in diameter, roughly the width of a human hair. This dust has accumulated over billions of years as countless meteoroids and asteroids have bombarded the moon's surface, pulverizing the rock into a fine powder. Unlike Earth, the moon possesses a negligible atmosphere, almost a complete vacuum. Consequently, there is no wind or water to erode and smooth the dust particles. Furthermore, constant exposure to the solar wind has imparted an electrostatic charge to the regolith, making it cling tenaciously to any surface it contacts. The Apollo astronauts learned this lesson firsthand. Moon dust clung to their spacesuits, infiltrated their lunar landers, and adhered to virtually everything. Even worse, it proved to be a health hazard, causing eye irritation and respiratory problems inside the spacecraft. But for now, it seems like a problem for future US. A much more important issue is finding water to support future missions, and China is going to deal with it. It's getting ready for a big mission to look for hidden ice on the moon. As part of the Chang'e 7 mission in 2026, a flying robot will explore deep craters at the moon's south pole where ice might be trapped. If they manage to confirm it, this could be a game changer for future lunar missions. Astonishing prospects lie ahead as we continue to explore our ancient, ever-fascinating moon. Imagine a future where lunar outposts are not just a dream, but a reality. These outposts will possess a vital water source and even the means to produce fuel for interplanetary voyages. China's ambitious mission to land astronauts on the moon within the next 5 years represents a monumental leap towards this vision, while previous missions, including China's Chang'e 5 probe and observations from NASA and Indian spacecraft, have detected traces of water in lunar soil. Scientists now believe that substantial, deeply buried ice deposits are the real key to sustained lunar habitation. The moon's south pole, a region characterized by incredibly deep impact craters, is thought to harbor vast quantities of this precious resource, locked away in perpetual shadow. The upcoming mission will deploy a specially designed flying robot to explore these dark craters after landing. Its mission: to locate and analyze potential ice deposits. The discovery of accessible ice would revolutionize lunar missions, drastically reducing their cost and logistical complexity, enabling astronauts to live and work on the moon for extended periods. Intriguingly, some scientists speculate that these lunar ice deposits could even offer clues about the origins of life beyond Earth. But regardless of whether we find water and conquer the challenges of lunar dust, the recent revelation of young lunar ridges has dramatically altered our understanding of our celestial neighbor. If the moon is still experiencing geological activity, it implies that our knowledge of this celestial body is far from complete. What other secrets does the moon hold? Are we truly prepared to confront the possibility that this seemingly inert satellite is, in fact, a dynamic and evolving world? Future lunar missions, potentially facing unforeseen hazards, will undoubtedly reveal more. For years, we believed the moon's volcanoes to be dormant, relics of a distant past. But that assumption has been shattered. China's Chang'e 5 mission delivered a stunning revelation. Lunar soil samples brought back to Earth contained evidence of volcanic eruptions occurring as recently as 123 million years ago. In geological terms, that's practically yesterday. But this begs the question: does this lunar activity pose any threat to us here on Earth? We've long been aware of the moon's volcanic past, evidenced by the dark, expansive plains known as lunar maria that dominate its surface. These maria, formed by ancient lava flows dating back 3 to 3.8 billion years, were once thought to represent the end of the moon's volcanic era. However, the Chang'e 5 mission yielded a treasure trove of lunar soil, including several microscopic glass beads. 3 of these beads, in particular, told an extraordinary story. Formed approximately 123 million years ago by volcanic eruptions, with an uncertainty range of just 15 million years. These tiny spheres are incredibly significant due to their composition and rarity. Measuring a mere 20 to 400 microns in diameter, smaller than a grain of sand, these beads are unequivocally volcanic in origin. This distinguishes them from the more common lunar glass beads, which are typically formed by the intense heat and pressure of meteorite impacts. When meteoroids strike the lunar surface, they melt the surrounding rock, creating a spray of tiny glass beads that are scattered across the landscape. In contrast, the volcanic beads discovered in the Chang'e 5 samples were formed when magma erupted from the moon's interior, rapidly cooling and solidifying into glass as it reached the surface. By employing uranium-lead dating, a technique that measures the decay of uranium into lead within the beads, scientists were able to determine their age with remarkable precision. The results indicate that the most recent known volcanic activity on the moon occurred within the last 200 million years, a relatively recent event in the moon's vast history. This discovery also corroborates previous observations of unusual surface features known as irregular mare patches. These patches, characterized by smooth, rounded mounds surrounded by rough, rocky terrain, were first identified by NASA's Lunar Reconnaissance Orbiter in 2014. The patches appear significantly younger than the surrounding lunar landscape, suggesting that they may have been formed by volcanic eruptions less than 100 million years ago. Prior to the discovery of the Chang'e 5 glass beads, these irregular mare patches were among the strongest evidence supporting the theory of recent lunar volcanism. But their origin remained speculative. Now, the glass beads provide definitive proof of recent volcanic activity. These findings ignite a flurry of new questions about the moon's internal processes. But here's the puzzle. How could such a small, celestial body retain enough internal heat to fuel ongoing volcanic eruptions? The prevailing scientific understanding was that the moon had largely cooled down after its formation some 4.5 billion years ago, rendering it volcanically inert. Without the dynamic forces of tectonic plate movement and lacking a substantial atmosphere, the moon should have dissipated its internal heat eons ago. Yet, these intriguing glass beads hint at the presence of localized heat sources nestled deep within the moon's mantle. The current hypothesis suggests that heat-producing elements such as potassium, K, and thorium, Th, may be concentrated in specific areas, creating small, intensely warm pockets. These pockets could generate sufficient heat to melt the surrounding rock, triggering sporadic and isolated volcanic eruptions. But the implications extend far beyond simply rewriting the moon's geological history. This discovery adds a captivating dimension to the ongoing investigations of transient lunar phenomena, or TLPs. These elusive sightings, often reported by amateur astronomers as fleeting ghostly glows or hazy patches on the lunar surface, have remained largely unconfirmed by scientific probes. Skeptics often dismiss them as mere optical illusions caused by distortions in Earth's atmosphere. However, if the moon does indeed harbor small pockets of volcanic or outgassing activity, these TLPs might have a tangible basis in reality. Gases venting from beneath the lunar surface could potentially explain these mysterious glows, offering a tantalizing hint of residual volcanic action still simmering beneath the moon's seemingly barren exterior. Now, if volcanic activity persists on the moon, even in a limited capacity, it could unlock exciting possibilities for future lunar missions. In the decades to come, astronauts might be able to harness this volcanic heat to generate power, melt subsurface ice into usable water, or even provide warmth for bases constructed on the perpetually frigid lunar surface. The revelations aren't confined to our own celestial neighbor. We're also expanding our knowledge of volcanic moons far beyond our solar system. The tantalizing detection of a potentially volcanic exomoon orbiting the distant exoplanet WASP-49b, located approximately 635 light-years away, suggests that volcanic activity may be a relatively common phenomenon among moons throughout the cosmos. Until recently, Jupiter's moon Io, formerly known as Io, reigned supreme as the most volcanically active body known to science. But now, researchers at NASA's Jet Propulsion Laboratory, JPL, may have identified a new contender for this fiery title. This potential exomoon first came to light when scientists observed an extensive cloud of sodium gas enveloping the exoplanet. Sodium clouds are unusual features in planetary atmospheres, and their presence can often be indicative of volcanic activity. The sodium cloud surrounding WASP-49b exhibited peculiar and unexpected behavior. It was moving erratically, fluctuating in size, and occupying a volume far too vast to be explained solely by the exoplanet's own atmosphere. Scientists theorize that this cloud could, in fact, be generated by a volcanically active exomoon locked in orbit around WASP-49b. Volcanic moons, such as Io, are known to vent copious amounts of gases, including sulfur dioxide, SO2, sodium, Na, and potassium K, which then coalesce to form massive clouds around their parent planet. Io, for example, regularly erupts vast quantities of gas that create a cloud encircling Jupiter, extending up to 1,000 times the size of the gas giant itself. If a similar process is unfolding near WASP-49b, the observed gas cloud could serve as compelling evidence of volcanic activity on a distant exomoon orbiting the planet. Observations gleaned from the European Southern Observatory's Very Large Telescope, VLT, in Chile appear to lend further support to this intriguing hypothesis. The sodium cloud surrounding WASP 49b is positioned high above the exoplanet's atmosphere and exhibits behaviors that are inconsistent with the exoplanet's rapid 2.8 Earth-day orbit. This suggests that the cloud may originate from a separate celestial body, most likely a volcanically active moon. Furthermore, WASP 49b and its host star are primarily composed of hydrogen, H, and helium, Chi, which makes the presence of a sodium cloud even more perplexing and suggestive of an external source. The observed rate of sodium release, estimated at over 220,000 pounds per second, points to an immensely powerful and sustained volcanic source. Should scientists definitively confirm the existence of this volcanic exomoon, it would represent a landmark achievement, the very first confirmed discovery of a volcanic exomoon beyond our solar system. Back in our own cosmic neighborhood, Io remains a crucial celestial laboratory, offering invaluable insights into the dynamics of volcanic moons. Recently, NASA's Juno spacecraft captured some of the closest and most detailed images of Io since the Galileo mission over 2.5 decades ago. Io's intense volcanic activity is driven by tidal heating, a consequence of the relentless gravitational tug-of-war between Jupiter and its neighboring moons, such as Europa. This constant gravitational flexing generates immense friction deep within Io's interior, producing heat that fuels its seemingly perpetual volcanic eruptions. One of Juno's most recent and exciting findings: the Juno mission yielded an extraordinary discovery. A brand new volcano had emerged just south of Io's equator. Imagine a world constantly reshaping itself before our very eyes. The images revealed a sprawling and complex volcanic region, approximately 111 by 111 miles in extent. What makes this truly astonishing is that this volcanic structure was completely absent when the Galileo spacecraft imaged the same location back in 1997. This infant volcano had sprung into existence near Kehek, a previously known volcanic feature. Researchers emphasize that the birth of this volcano represents a dramatic change, underscoring the incredibly dynamic nature of Io's surface. Io's equatorial region is a hotbed of volcanic activity, owing to the concentrated tidal heating it experiences. The most potent eruptions unleash sulfurous gases and give rise to brilliant lava flows. These eruptions blanket the moon in colorful sulfur-rich deposits, creating a landscape unlike any other in our solar system. JunoCam, from a distance of approximately 1,570 miles, captured a breathtaking image of Io, dramatically illuminated by sunlight reflected off Jupiter. Before us unfolds a stunning vista of a volcanic surface in constant flux. Despite these detailed observations, Io's volcanism remains shrouded in mystery. Scientists are particularly intrigued by the influence of tidal heating on Io's internal structure and whether a subsurface magma ocean exists beneath the moon's crust. They are also striving to decipher the triggers for different types of eruptions, such as the formation of plumes versus the effusion of lava flows, and how volcanic gases mold Io's surface and its tenuous atmosphere. The study of volcanic moons, from Io to the potential exomoon orbiting WASP 49b, offers valuable insights into how tidal forces drive volcanic activity on diverse celestial bodies. On icy moons like Europa, tidal heating sustains liquid oceans beneath the surface, potentially creating habitats for life. However, on Io, which lacks an ocean, these same forces instead fuel intense volcanic activity. Furthermore, if volcanic exomoons, such as the one possibly orbiting WASP 49b, are confirmed, we may soon discover a multitude of volcanic worlds scattered across the galaxy. Now, let's shift our focus from the fiery landscapes of Io to a more fundamental concept: time itself. Imagine that time can stretch or compress depending on your location. If you were to ascend to the summit of an extremely high mountain, time would pass ever so slightly faster than if you were down in a valley. This is due to the effects of gravity on time. While these differences are imperceptible in our daily lives, they are of paramount importance to scientists and space agencies preparing to send humans to the moon. A new space race is underway, with numerous nations vying to establish long-term bases on the moon. With human presence on the lunar surface, reliable timekeeping becomes absolutely essential. However, the moon does not operate on Earth's time. A day on the moon elapses slightly faster than a day on Earth, with a difference of approximately 56 microseconds. This may seem insignificant, but over time, even such a minuscule difference can accumulate, leading to significant discrepancies. To ensure the smooth operation of lunar missions and prevent synchronization issues, NASA and scientists worldwide are tackling a challenging task, creating an entirely new lunar timescale. NASA plans to implement this new timescale by 2026, the same year it hopes to send astronauts back to the moon for the first time in half a century. This lunar timescale is not merely a time zone. It is a comprehensive system designed to account for the moon's faster time and maintain synchronization with Earth's time systems. Only then can lunar missions proceed seamlessly. On Earth, our timekeeping system is already surprisingly intricate. While time may seem like a straightforward concept, maintaining accurate time is a precise science, particularly when considering the profound impact of timekeeping on our daily lives. To ensure global time coordination, scientists rely on Coordinated Universal Time, or UTC. This global time standard is based on ultra-precise atomic clocks, located in various locations around the world. Atomic clocks are remarkable instruments that measure time based on the consistent vibrations of atoms, ensuring exceptional stability and accuracy. This enables scientists to maintain UTC as a unified standard for everyone, everywhere. These atomic clocks also account for the fact that time slows down slightly as you approach the center of our planet. Consequently, atomic clocks situated closer to the Earth's surface tick slightly slower. Imagine a world where time itself bends to the will of gravity. Here on Earth, the relentless pull of our planet affects the passage of time ever so slightly. According to Einstein's theory of relativity, gravity warps the fabric of space-time, causing clocks at different elevations to tick at different rates. To maintain universal time, scientists meticulously distribute atomic clocks across varying altitudes, averaging out these minute discrepancies. To further refine our temporal precision, leap seconds are occasionally added to compensate for subtle, natural fluctuations in Earth's rotation. It sounds incredibly complex, but this dedication to synchronized timekeeping is the invisible foundation upon which our modern world is built. Precise timing is absolutely essential for global trade, ensuring transactions occur seamlessly across continents. It's also crucial for GPS navigation, guiding ships and aircraft with pinpoint accuracy, and it's the backbone of internet communications, enabling data to flow instantaneously around the globe. But what about the moon? Time operates under different rules on our celestial neighbor. The moon's gravitational field is significantly weaker than Earth's. Consequently, clocks on the moon would tick slightly faster. This seemingly small difference could cause lunar clocks to gradually drift out of sync with Earth time if left uncorrected. Such a discrepancy could lead to critical problems, especially when astronauts need to maintain constant contact with mission control or navigate the challenging lunar terrain. NASA's ambitious solution is the creation of a dedicated lunar timescale. The plan isn't to force moon clocks into perfect alignment with Earth. Instead, the goal is to establish a unique system designed to accurately measure time on the moon, while also providing a straightforward method for converting it back to Earth time. Think of it as building an entirely new temporal framework specifically tailored for the lunar environment. To bring this lunar time system to life, NASA is collaborating with international partners, including the European Space Agency. Together, they are developing a network called LunaNet. This lunar network will function much like the Internet, but for the moon. It will ensure that all lunar clocks operate in harmony and are synchronized with Earth-based time. Just as atomic clocks around the world coordinate to maintain Coordinated Universal Time, UTC, on Earth, clocks on the moon will be integral to the vast LunaNet system. Scientists have considerable experience in the field of managing time in space. Consider the Global Positioning System, GPS satellites, which orbit Earth at an altitude of approximately 12,550 miles. These satellites carry incredibly precise atomic clocks. Due to their distance from Earth's gravitational pull, these clocks tick faster than clocks here on the surface. So, how does GPS navigation maintain its accuracy? The answer is that scientists have developed techniques to slow down the satellite clocks, synchronizing them with Earth time. This experience with GPS clocks provides a solid foundation for the challenges of timekeeping on the Moon. In some ways, managing time on the Moon may prove simpler than managing GPS. Scientists can utilize lunar clocks in their natural state, rather than forcing them to perfectly synchronize with Earth. By establishing an accurate lunar time system from the outset, they hope to avoid some of the complexities associated with managing GPS satellites. Here's where things get particularly interesting. To ensure the viability of lunar timekeeping, NASA and its partners intend to deploy clocks both on the lunar surface and on satellites orbiting the Moon. Some of these will be long-lasting atomic clocks, while others will be crystal oscillators, which offer exceptional stability over shorter durations. Together, these clocks will form a reliable network for scientific operations. However, atomic clocks, designed for space applications, are not cheap. They can cost several $1,000,000 each. Crystal oscillators are more affordable, but they lack long-term accuracy. Once deployed, these clocks will operate as part of LunaNet, NASA's comprehensive framework for all moon-based time and data networks. LunaNet will essentially function as an internet for lunar operations. Various space agencies will contribute to the network, much like internet service providers operate on Earth. But another set of challenges arises from the Moon's unique rotation. A lunar day is significantly longer than an Earth day, as the Moon takes approximately 28 Earth days to complete a full rotation. Furthermore, the lunar equator experiences about 14 days of sunlight followed by 14 days of darkness. Unlike Earth's predictable day-night cycle, the Moon's south pole, where NASA plans to establish future lunar missions, contains areas that are perpetually lit or perpetually shadowed, potentially complicating astronaut activities. Imagine, for a moment, the complexities of life beyond Earth. As humanity ventures further into the cosmos, the simple act of telling time becomes a monumental challenge. NASA, in collaboration with its international partners, is embarking on an ambitious project, establishing a universal lunar timescale. They are engaging organizations such as the International Astronomical Union, seeking global consensus to ensure that all lunar explorers operate on the same temporal framework. This endeavor extends beyond mere timekeeping. It's a crucial stepping stone for future interplanetary missions, particularly those bound for Mars. The expertise gained from creating a lunar time system will serve as a vital blueprint for managing time on more distant worlds. Scientists recognize the profound implications of this lunar project. For astronauts residing on the Moon, a consistent and reliable time system will be indispensable not only for navigation, but also for conducting scientific experiments and managing daily life. NASA's Lunar Time Project is a pioneering endeavor, marking the initial stride toward managing time as humans extend their reach into the vastness of space. If successful, it will provide future astronauts with not only Earth time, but also a dedicated lunar time, and eventually, even a Martian time. Precise timekeeping is paramount, both for scientifically comprehending the passage of time on the Moon and for establishing the infrastructure necessary to execute missions seamlessly. Scientists are enthusiastic about developing a timescale from the ground up, leveraging their accumulated knowledge of terrestrial timekeeping to create a novel system tailored for the Moon. But that's not all that's happening on our celestial neighbor. Something unexpected is unfolding deep within the Moon. It's not a dramatic event visible from the surface, but rather a revelation within its hidden layers. Scientists have detected a previously unknown layer of what can only be described as moon goo. Remember your school lessons about the Earth's structure, the crust, mantle, and core? Similar to Earth, the Moon comprises these layers, although the Moon's core is significantly smaller in comparison. Earth's core constitutes approximately 1/3 of the planet's total mass, while the Moon's core accounts for a mere 1 to 2%. Its diameter is only about 1/5 of the Moon's overall diameter. This core is encased by a rigid rocky mantle. However, nestled between these two layers lies a mysterious, partially molten layer, the goo, and it holds far greater significance than one might imagine. This layer is soft and partially molten, flowing like the tides of our oceans. It undulates, stretches, and shifts, almost as if it were alive. Its movement is not erratic, but rather subtle and regular. We've long understood that the moon influences our oceans, causing tides through its gravitational pull. But it turns out that we influence it in return. This molten ocean responds to the gravitational interplay between Earth and the Sun. Moreover, this molten layer may be composed of ilmenite, a remarkably intriguing material. Ilmenite is abundant in titanium, a strong yet lightweight metal highly valued on Earth. Titanium finds applications in a vast array of products, from aircraft components and spacecraft to medical devices and everyday items like bicycles and laptops. Its strength, corrosion resistance, and heat resistance make it indispensable. If the moon harbors a molten layer rich in ilmenite, it could revolutionize lunar exploration. Astronomers are already envisioning lunar bases, and having readily available materials for constructing structures, spacecraft, or tools for astronauts would be transformative. The alternative, transporting materials from Earth, is prohibitively expensive. This discovery serves as concrete evidence that the moon is not merely a cold, inert rock. Rather, it is a dynamic, living entity with active forces churning beneath its surface. NASA employed advanced tools to unveil this hidden layer. The Gravity Recovery and Interior Laboratory, GRAIL, and the Lunar Reconnaissance Orbiter, LRO. These space missions are specifically designed to study the moon's interior. Unlike telescopes that merely observe the surface, these missions measure unseen properties, such as the moon's gravity and its variations over time. GRAIL deployed 2 small spacecraft named Ebb and Flow into lunar orbit. Imagine 2 spacecraft flying in precise formation, almost touching as they orbit the moon. Their mission: to detect the faint, almost imperceptible variations in lunar gravity. It's as if they're feeling the moon's mysterious pull, sensing how it differs from one location to another. If the moon's gravitational field strengthens in a particular area, the spacecraft are drawn closer together. Conversely, if the gravity weakens, they drift slightly apart. This delicate dance provides scientists with invaluable insights into the moon's hidden interior, even without setting foot on its surface. These probes ultimately met a dramatic end, intentionally crashing into the lunar surface in December 2012, concluding their mission. But the story doesn't end there. The Lunar Reconnaissance Orbiter, LRO, continues the work, capturing ultra-high-resolution images and gathering critical data about the moon's surface composition and features. By combining the data from both the GRAIL mission and the LRO, scientists have made a startling discovery: evidence of a goo layer deep within the moon. This finding throws lunar geology into disarray, challenging long-held beliefs. How did this molten or semi-molten layer come to exist? How long has it persisted beneath the surface? And perhaps most puzzling of all, what has kept it warm for eons? These are million-dollar questions that have scientists scratching their heads. The moon, like Earth, possesses a core that generates heat. However, it's not as simple as attributing the molten layer's warmth to the core's energy. The moon's core is significantly smaller and less active than Earth's, producing far less heat. Moreover, the moon is a frigid world, with surface temperatures plummeting to 200 degrees Celsius. How can this internal layer maintain its flowing state in such a cold environment? The answer remains elusive. Nevertheless, this discovery of this goo has the potential to unlock many mysteries about the moon. For instance, astronomers have long been puzzled by moonquakes. The shifting and movement of this semi-molten layer beneath the surface may be the key. The implications extend far beyond the moon itself. If the moon, once considered a static, unchanging rock, harbors such dynamic internal activity, what about other celestial bodies? Could similar hidden processes be occurring beneath the surfaces of other planets, moons, or even asteroids? This realization could also help us to better understand Earth itself, shedding light on the workings of tides and other geophysical phenomena. And the lunar revelations keep coming. Recently, scientists have uncovered evidence of vast, ancient cave systems hidden beneath the moon's surface. For over half a century, the possibility of underground tunnels and caverns, known as lava tubes, has been considered. These lava tubes are a direct result of the moon's volcanic past. Millions of years ago, the moon experienced intense volcanic activity, resulting in widespread eruptions. As lava flowed across the surface, the outer layers cooled and solidified, forming a protective roof of dark rock. This is what gives rise to the dark patches we see on the moon, the hardened remnants of ancient lava flows. Beneath this solidified crust, hot molten lava continued to flow. Once the eruption ceased and the lava drained away, it left behind a hollow tunnel, a lava tube. We see similar structures on Earth, in volcanically active regions like Hawaii and Iceland. But the lunar lava tubes dwarf their terrestrial counterparts. In fact, they are believed to be among the largest and longest in the entire solar system. One such cave, located beneath the Sea of Tranquility, Mare Tranquillitatis, the landing site of Apollo 11, plunges to a depth of at least 340 feet. These extensive lava tube systems have remained hidden just below the surface for millions of years, undisturbed and pristine. Only now have scientists definitively confirmed their existence. Researchers from the University of Trento in Italy employed specialized radar technology and advanced computer analysis to peer beneath the lunar surface. By sending radar waves and analyzing their reflections, they were able to detect the shape and size of these hidden caverns. The discovery of these lava tubes opens up exciting possibilities for future lunar exploration. They could serve as ideal locations for establishing lunar bases, offering protection from radiation, harsh solar winds, and meteorite impacts. NASA has even identified potential locations for future lunar habitats within these subterranean shelters. Imagine a world where humanity has a second home amongst the stars. Evidence suggests that deep within the moon's mysterious cave systems, the temperature remains a constant, almost cozy, 63 degrees Fahrenheit. This remarkable stability opens up incredible possibilities. And there's more, the tantalizing prospect of water ice hidden within these lunar caverns. Humans could potentially find shelter within these natural tunnels, constructing entire colonies on the moon, shielded from the harsh radiation and extreme temperature swings of the lunar surface. Now, I know what some of you are thinking. Could terrifying, unknown lunar monsters lurk in the inky blackness of these caves? While the potential for extraordinary discoveries within these hidden realms is immense, the likelihood of stumbling upon complex life forms is slim. Even if we were to uncover a miracle, perhaps small life or microbial organisms, there's a very high chance that we won't find actual animals or monsters. The conditions simply wouldn't support their development. Still, it's the perfect setup for a sci-fi horror masterpiece, isn't it? Before we send humans into these unknown depths, researchers are planning to deploy robots and drones to scout the tunnels, assessing their safety and mapping their layout. And it's not just the United States leading the charge. China is also actively exploring the possibility of establishing a future lunar base within these moon caves, signaling that the race to explore and ultimately settle the moon is rapidly intensifying. But there's a strange phenomenon occurring on our celestial neighbor. The moon is rusting, and the culprit might be Earth. It seems improbable, considering the vast distance of over 230,000 miles that separates our two worlds. However, a unique connection exists. The moon exerts a powerful influence on our planet, most visibly through the ocean tides. As Earth rotates, the moon's gravitational pull tugs on the water on our planet's near side, creating a bulge. Simultaneously, another bulge forms on the opposite side due to centrifugal forces generated by Earth's rotation. Our planet continues to spin beneath these bulges, resulting in the too high and too low tides we experience each day. Furthermore, the moon's slight wobble and tilt cause subtle variations in these tidal patterns. And in a surprising twist, Earth's atmosphere seems to be causing the moon to rust. Rust, that familiar reddish coating found on aged iron, like old gates or nails. Remember the Vermilion Cliffs and the Grand Canyon? Their distinctive red hues are a result of iron oxide, or rust, within the rocks. Rust forms when iron reacts with oxygen and water, a common process even on Mars, where the planet's signature color originates from ancient, widespread oxidation. This is how the red planet earned its nickname. Typically, the moon wouldn't be considered a likely candidate for rusting, given its dry environment and virtually non-existent atmosphere. However, a spacecraft studying the moon in 2008 detected spectra, wavelengths of light reflecting off the lunar surface, allowing for a detailed analysis of its composition. The data revealed that the lunar poles possessed a different composition than the rest of the moon, containing rocks rich in hematite, a specific type of iron oxide or rust. This discovery was unexpected, as the conditions on the moon shouldn't favor the formation of significant amounts of rust. Yet, we know that traces of water exist on the lunar surface. This revelation has sparked new theories about the potential materials hidden beneath the moon's surface, suggesting that they may have formed through reactions between water and rocks. For iron to acquire its characteristic rusty hue, it requires an oxidizer, a molecule that strips electrons from materials like iron, with oxygen being a prime example. However, the relentless solar wind bombarding the moon carries hydrogen, which has the opposite effect, donating electrons to other molecules. Earth benefits from a protective shield against the solar wind, our magnetic field. But the moon lacks such protection, making rust formation on its surface seem improbable. Yet this process is occurring, and Earth may be the cause. The moon's own atmosphere is too thin to provide sufficient oxygen for iron to rust, but our generous planet donates a portion of its own atmosphere. Oxygen from Earth travels vast distances to the moon, following a pathway known as the magnetotail, a long extension of Earth's magnetic field that can reach the near side of the moon. Imagine standing on the lunar surface, millions of miles from Earth. It's a desolate landscape, and yet, even here, we find the unexpected. Hematite, a form of iron oxide, or rust. This discovery poses a fascinating mystery. Now, picture a full moon. During this time, our planet's magnetotail acts like a shield, deflecting almost all of the solar wind that would otherwise bombard the moon. It's as if a temporary curtain has been drawn, providing a brief window for rust to potentially form. But there's a catch. Rust needs water, and water isn't exactly abundant on the moon. Most of it exists as ice, hidden away in permanently shadowed craters, far from where the hematite deposits were found. So, how did the water get there? An intriguing theory suggests that countless dust particles constantly bombarding the moon could be liberating water molecules trapped within the lunar surface. This process could then mix the water with iron, setting the stage for oxidation. Furthermore, these very dust particles might themselves be carrying water. Their impacts could generate heat, accelerating the oxidation process and leading to even more rust formation. But it's not just the Earth influencing the moon. Humankind, too, has left its mark. Back in 1959, a probe became the first human-made object to touch the lunar surface. This marked the beginning of what scientists are now calling the Lunar Anthropocene, a period where human activity is measurably altering the moon. Think of it as an analogy to Earth's Anthropocene, where our actions have profoundly impacted the planet's environment. While pinpointing an exact start date is difficult, there's no doubt that our activities have reshaped our homeworld. And now, even without permanent residence on the moon, we've already left our traces. Since those first lunar missions, we've sent many more. We've left behind landers, flags, and scientific instruments. We've moved lunar soil, brought golf balls, and even left human waste. The future holds even grander plans. More missions, the potential for lunar habitats, and the exploitation of the moon's resources to send back to Earth. That's precisely why discussing the Lunar Anthropocene is so crucial. It serves as a reminder of our responsibility to protect our shared heritage. And what about seeing the moon during the day? Many are puzzled by this phenomenon, some even believing it's a recent occurrence, fueled by blurry pictures of a daytime full moon circulating online. There are even unusual theories that the sun's color has changed, supposedly appearing more yellow in the past. But the sun hasn't changed. It remains a blue-green star. Perhaps our perception of it as more yellow stemmed from lower pollution levels in our youth. As for the moon, it's always there, day and night. It's simply more visible at night due to the absence of the sun's glare. During the new moon phase, however, the moon is very close to the sun in the sky. The intense scattered sunlight overwhelms the faint light reflected by the moon, rendering it nearly invisible for a couple of days. Speaking of lunar phases, they're easy to grasp with a bit of knowledge. Take the black moon, for instance. This term can refer to two different events, either two new moons occurring in a single month or a month, typically February, with no new moon at all. The blue moon, despite its name, isn't about color. It's the third full moon in a season that boasts 4 full moons, and the supermoon occurs when a full moon coincides with the moon's closest approach to Earth in its elliptical orbit, making it appear larger and brighter than usual. Then there are times when you gaze up at the night sky and witness an eerily red sphere hanging above. This isn't a harbinger of the apocalypse or a sign of werewolves on the prowl, though the blood moon certainly inspires such tales. Imagine a spectacle in the night sky, a celestial ballet where our own planet casts a reddish hue upon the moon. This isn't magic, but a total lunar eclipse, a cosmic alignment where Earth positions itself precisely between the sun and its faithful satellite. As the sun's rays graze our atmosphere, they paint the lunar surface with a soft, ethereal red. But the moon is becoming more than just a pretty sight. Whispers from the lunar South Pole hint at a new era of lunar construction, all thanks to India's recent moon mission. The Discovery. Sulfur, a surprisingly versatile element that could be essential for building structures on our celestial neighbor. For the first time, this chemical element has been discovered on Earth's natural satellite. This element, often found near Earth's volcanoes, speaks volumes about the moon's fiery past and the atmospheric conditions that once prevailed. The lunar rover detected this sulfur less than a week after its historic landing, a mere 70 degrees from the moon's south pole, on August 23, 2023. This remarkable achievement made India the 4th nation to achieve a successful lunar landing. More than that, it was the first spacecraft to ever touch down so close to the South Pole, a region of immense strategic importance. Why? Because it's believed to harbor vast deposits of water ice. If this proves true, future missions could potentially harvest this ice, transforming it into everything from drinking water to rocket fuel. For 2 weeks, the lunar lander meticulously gathered data, focusing mainly on analyzing the lunar soil and its incredibly thin atmosphere. Simultaneously, the solar-powered Pragyan rover embarked on its own quest to locate frozen water on the moon. But the lander wasn't finished showcasing its capabilities. On September 3rd, it executed another astonishing feat. Firing its engines, the spacecraft briefly lifted itself about 16 inches into the air before making a controlled hop, landing a short 12 to 16 inches from its original position. This seemingly small hop is actually a monumental step. The ability to lift a lander off the lunar surface is crucial for future missions, proving that we can safely retrieve soil samples, or even astronauts, after a stay on the moon. In September, the Indian spacecraft was placed into sleep mode. The long, frigid lunar night, lasting 14 Earth days, was approaching, and the spacecraft wasn't designed to operate during this period. However, the mission had already yielded some significant discoveries. One revelation involved measuring the temperature of the lunar soil at various depths. Surprisingly, the surface in that region turned out to be much hotter than anticipated. While scientists estimated a surface temperature between 68 and 86 degrees Fahrenheit, it was actually a scorching 158 degrees Fahrenheit. Another key finding was the confirmation of several chemical elements, including the presence of oxygen. Data also confirmed the existence of aluminum, calcium, iron, titanium, silicon, and other elements near the lunar South Pole. The rover also employed specialized instruments to detect seismic activity, listening for quakes and rumbles beneath the lunar surface. And this brings us back to the sulfur, detected by the rover's spectroscope. Scientists are now working to determine its origin. Did it form naturally on the surface, or is it a result of past volcanic activity, or even a meteor strike? Adding to the moon's mysteries, an extraordinary discovery has emerged. A rock that may be the oldest known fragment of Earth. A tiny 0.7-inch chip, part of a larger rock sample, brought back by Apollo astronauts, could be a 4 billion-year-old piece of our own planet. This astonishing find could help us reconstruct the violent early history of Earth. The scenario might unfold like this. Shortly after the rock formed, a massive asteroid impact could have ejected it from Earth. At that time, the Moon was much closer to Earth, 3 times closer than it is today. The force of the collision was so immense that this fragment of terrestrial rock was propelled all the way to the Moon. There, it became embedded in a lunar breccia, a kind of molten rock. Eventually, this precious rock was brought back home. Imagine, for a moment, a rock brought to our planet by Apollo 14 astronauts. Prior to this, meteorites originating from Mars and the Moon had been identified, but this was unprecedented. A lunar rock revealed itself to be, in essence, a terrestrial meteorite. Astonishingly, analysis revealed that the rock had taken shape within a water-rich environment, subjected to temperatures and pressures mirroring those found approximately 12 miles beneath Earth's surface. An incredible glimpse into our own planet's history, delivered from the Moon itself. Fast forward to 2019, and China's Chang'e 4 mission etches its place in history, achieving the first-ever landing on the far side of the Moon. The mission's rover became instrumental in allowing researchers to visualize structures concealed far beneath the lunar surface, unlocking eons of lunar history. The U-22 rover accomplished this feat utilizing its lunar-penetrating radar, a technological marvel that could image deep into the Moon's hidden layers. It listened intently for echoes, sound waves rebounding off structures hidden from view, buried under the lunar crust. What the rover uncovered was astounding. These structures lay at depths reaching nearly 1,000 feet. The data suggests that the initial 130 feet beneath the surface consist of stratified layers of dust, soil, and various rocky materials. Moreover, the instruments pinpointed a concealed crater, a scar left by an ancient impact event when a large object collided violently with the Moon's surface. Eons ago, molten lava likely flowed beneath the surface. Researchers surmise that the fractured rocks surrounding this formation are likely debris, remnants of that cataclysmic impact. The analysis also revealed that volcanic rock layers exhibited a thinning trend as they approached the surface. This variation in the thickness of lava flows may indicate a gradual decline in both the frequency and intensity of volcanic eruptions over vast stretches of time. Lunar volcanic activity, it seems, steadily waned following the Moon's formation approximately 4.5 billion years in the past. On the far side of the Moon lies one of the solar system's most immense and ancient impact craters, the South Pole Aitken Basin. From Earth, alas, we can only observe its outer rim, presenting as a colossal chain of mountains. This gargantuan depression plunges to a depth of 8 miles and extends across a staggering 500 miles in diameter, encompassing approximately 1/4 of the Moon's total surface area. Astronomers are convinced that this colossal crater owes its existence to an asteroid impact that occurred around 4 billion years ago. And now, an astonishing discovery. A gigantic mass of metal, comparable in size to 4 Connecticuts, lurks beneath the lunar surface. Its weight defies easy comprehension, a number so immense it requires 18 zeros to express in pounds. This enigmatic mass lies approximately 180 miles below the Moon's surface, nestled within the South Pole Aitken Basin. Its discovery came about through data collected by GRAIL, NASA's Gravity Recovery and Interior Laboratory mission. While examining the data, scientists discerned a peculiar anomaly, a localized shift in gravity. Upon investigating this phenomenon, they determined that something substantial was exerting a gravitational pull on the basin floor. The precise nature of this bizarre mass remains unknown, fueling intense speculation. One theory suggests that it is a concentration of dense oxides formed during the Moon's primordial stages as it cooled from a molten state. At that time, the lunar surface was covered in magma oceans, and this lump could have solidified during the final phases of cooling. However, the prevailing theory points to the idea that this puzzling mass is a fragment of the colossal asteroid, responsible for creating the South Pole Aitken Basin. Given its metallic composition, it is likely the iron-nickel core of that ill-fated asteroid. But the mysteries of the moon don't end there. Evidence suggests the presence of an expansive network of lava tubes beneath the lunar surface. Recently, astronomers analyzed underground topography data, revealing a massive cave concealed beneath our natural satellite's surface. This could be a relic of lunar volcanic activity that occurred over 3 billion years ago. Streams of molten lava solidified, forming a robust outer crust. However, within, the lava continued to flow, eroding and melting the rock, thus creating subterranean tunnels and caverns. Numerous small pits observed on the moon's surface, discovered by NASA, appear to be entrances to these very lava tubes. Should this theory be confirmed, these underground tunnels could provide not only a safe haven for future human space missions, but also a vital source of water for astronauts, a critical resource for long-term lunar habitation. Imagine, back in 1969, humanity embarked on an ambitious project, lunar exploration. There were hurdles, certainly, but the unwavering determination of astronomers promises a return to the moon soon, armed with superior knowledge and cutting-edge technology. But what if an 800-year-old concept could prove even more valuable than the most sophisticated GPS technology and powerful rockets? Enter the Fibonacci sphere. Picture this. Scientists at a Hungarian university, deep in lunar research, stumbled upon an idea. They believe it holds the key to unlocking a deeper understanding of the moon's rotation and its slightly imperfect spherical shape as it orbits Earth. We often envision our planet and its celestial companion as perfect spheres suspended in the void. The reality, however, is quite different. Both are more akin to slightly deflated soccer balls, warped by the relentless forces of gravity, rotation, and tidal effects. The GPS technology we rely on daily here on Earth already accounts for these imperfect proportions. After all, our planet is subtly flattened at its poles. Thus, to create an accurate mapping system for the moon, we must consider its unique shape, the selenoid, essentially the lunar equivalent of Earth's geoid. The moon, being less compressed than our home planet, has allowed scientists to take a shortcut, treating it as a simple sphere. However, with a surge of new lunar projects on the horizon and the tantalizing prospect of manned missions, greater precision is paramount. Scientists are now convinced that acquiring accurate data is essential to painting a true picture of the moon. This is where the Fibonacci sphere enters the equation. It's a brilliant solution, long employed by mathematicians to evenly distribute points on a sphere. Recently, scientists harnessed this method to map approximately 100,000 points on the moon, utilizing previously collected data from NASA. The discoveries were pivotal to our understanding of the moon's true form. For instance, we now know that the lunar poles are roughly 0.3 miles closer to the center than the equator. While seemingly a minor detail, incorporating it into our GPS software before future lunar landings could prevent potential mishaps. This level of mathematical precision hasn't been applied to lunar mapping since the 1960s. However, its proven effectiveness on Earth fuels scientists' confidence as they prepare for upcoming missions. This isn't the first instance of Fibonacci's insights leading to ingenious solutions. It has found applications in fields ranging from finance and agriculture to computer science. Let's journey back to the origins of this remarkable sequence. Legend has it that the Italian mathematician Leonardo Pisano, better known as Fibonacci, initially had little interest in mathematical sequences. His fascination lay with rabbits. He devised an intriguing puzzle. What would happen if a pair of rabbits were placed in an enclosed space for a year? He established certain theoretical rules. All rabbits come in male-female pairs, capable of reproduction after 1 month. Each month, every rabbit pair produces 1 additional pair of offspring. Lastly, all rabbits remain impervious to harm for the entire year. Upon performing the calculations, he arrived at a series of numbers. 1, 1, 2, 3, 5, 8, and so on. Examining this sequence, you'll observe that each number represents the sum of the 2 preceding numbers. The first 2 ones represent the initial rabbit pair. The number 2 signifies the original pair plus their first offspring. This intriguing sequence gained traction, captivating math enthusiasts who began studying it intensely. They soon discovered its prevalence in nature, evident in the arrangement of leaves on a stem and the spiral patterns of seeds in sunflowers. You can even conduct a simple experiment to witness it firsthand. Grab paper and pen and attempt to draw the Fibonacci spiral. Begin with a tiny circle, then gradually increase its size, adhering to the Fibonacci numbers. The first circle should be a mere dot, essentially 0. The next, 1 unit. Another, still 1 unit. Continue this process, and you'll observe the circles forming a spiral pattern. Even as it expands, the spiral maintains its distinctive shape. You may have encountered. Imagine a hypnotic spiral, that mesmerizing Fibonacci sequence swirling before your eyes. Is it truly capable of inducing a trance? The evidence remains elusive, yet its impact on our focus and visual perception is undeniable. Stare intently at a spinning spiral, and you might begin to perceive objects shrinking or expanding, an illusion born from the direction of the swirl. It's not hard to understand why some people find this sensation so captivating, even hypnotic. This intriguing numerical series subtly permeates our daily existence, often unnoticed, but it also has practical applications, such as converting miles into kilometers. Observe the sequence: 1, 2, 3, 5, 8, 13, and so on. Select any 2 adjacent numbers, say 13 and 21. Perform the calculation, and you'll discover that 13 miles approximates 21 kilometers. The same principle holds true for 34 and 55. Music and mathematics, seemingly disparate disciplines, are intertwined. Wolfgang Amadeus Mozart, the musical genius, harbored a deep fascination with numbers from his early years. He delighted in uncovering hidden numerical patterns within music, almost like secret codes. Even his sister recalled his constant mathematical doodling, often scribbled on the very margins of his musical scores. Some scholars even speculate that Mozart may have explored the Fibonacci sequence, potentially employing its ratios to achieve balance within his compositions. And what of other art forms? Leonardo da Vinci, the Renaissance master, is believed to have incorporated the golden ratio into his iconic creations, such as the Vitruvian Man and the Mona Lisa. In the realm of grand architecture, the Parthenon may also embody this pattern. Whenever you encounter buildings adorned with perfectly spaced columns, you can be fairly certain that the builders drew inspiration from this mathematical harmony. The Great Pyramid of Giza stands as another compelling example. While no official records exist to confirm its deliberate use, the pyramid's proportions so closely align with the golden ratio that it seems almost self-evident. This pattern also manifests organically in our natural world. Venture into your garden and examine any pine cones you find. Notice the arrangement of the scales? They follow a pattern dictated by the Fibonacci sequence. Even the bones within our bodies appear to adhere to these same proportions. Consider our basic anatomy: 1 torso, 1 head, 1 heart. Then, observe the elements that come in pairs: arms, legs, eyes, and ears. Turning to the number 3, think about the segments of our limbs and the 3 distinct sections of our hands: the wrist, the palm, and the fingers. And speaking of fingers, their bone lengths also reflect this ratio. This design facilitates the smooth and fluid movements of our fingers, particularly when grasping objects. The Fibonacci sequence can be observed in the elegant curvature of ocean waves and the branching patterns of rivers as they split and flow. Weather phenomena, too, often adhere to this principle. Certain whirlpools and hurricanes develop and expand in a manner mirroring the Fibonacci spiral. Zoom out, and you'll realize that spirals aren't confined to Earth. They are ubiquitous throughout the cosmos. And this is no random occurrence. The vast majority of galaxies, including our own Milky Way, exhibit a spiral structure. Picture it this way. Within a nascent galaxy, stars don't emerge simultaneously. Some evolve more rapidly, while others progress at a more leisurely pace. This disparity in development causes gravity to exert its influence in varying ways, compelling the young galaxy to spin like a disk. As it rotates, these gravitational forces stretch and shape the galaxy, giving rise to its characteristic spiral arms. Conversely, if all the stars within a young galaxy were to appear concurrently, gravity would simply compress the matter into an ovoid shape, what astronomers term an elliptical galaxy.